Hello everyone, this is Udaditya from TechSpark. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with a comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to talk about data lake and data warehouse. We're going to understand the concepts behind these two and at what context should we use them. But before even going into that, let us talk about data first. What is data and how it actually looks like in the real world? Data is a collection of facts, numbers, words, observation, or other useful information that can be used to learn about something. Now, in the real world industry, if anyone is trying to making a report or a dashboard, the first thing he would require is the data. Only out of which he can underline the attributes and he can get the fields and the required columns to present the same in the report. So let me show you one picture over here. And there are three forms of data or in three various kinds of data that has been presented over here. One is the unstructured data at the left, which are just some random lines or some text. The university has 5,600 students. John's ID is number one. He's 18 years old. So out of this data, it's not really easy for us to understand the attributes or the fields which we require to analyze or even create a report. Now coming to the second one, that is the semi-structured data. You can see some tags over there like university, student ID, name, age, degree. So you get an idea. So there are some attributes present, but not in the most visually representative way. But if you look at the third one, that is the structured data, you can see it's a tabular format data which has the columns that we require like ID, name, age, degree, and for each and every column, there are specific set of values. So we can easily understand each and every field by just looking at the data. So that's easy. So that's how much easy for us to analyze a structured data than that of semi-structured and unstructured data. For unstructured data, it's nearly impossible for us to understand the attributes of the data. For semi-structured, yes, it is a bit understandable to look at the data to understand the tags. However, it's an XML format data, so that's why there are some tags. In the JSON format also, there are some dictionary, but those are not in the most tabular formatted way presented the way it is in the structured data. Now, we have these kinds of data, right? The unstructured, semi-structured, and structured. So they are the difference through which we can, by which we can analyze what is the best fit for us. But to load this data or to put this data, be it unstructured, semi-structured, or structured, we need a repository. We need some kind of a warehouse or some place where we simply sync the data in. So that's where the data lake and data warehouse comes in. Now, first, let us understand what is data lake. A data lake is a centralized repository for storing, processing, and securing large amounts of data in its original format. Data lakes can store any type of volume of data, be it structured or unstructured. Now, we all have mobiles or laptops, right? And in our mobiles or laptops, we have file manager, or we say the Windows Explorer. Okay, so what we do, we create some folders over there and then we keep our file. It can be an audio file, it can be a video file, it can be a document, it can be any sort. While keeping those files, do we create any sort of schema or any sort of predefined structure? No. We just put the file over there and that's done. So data lake is something like that. It can it can support any sort of structure, be it or it can support also the unstructured or semi-structured data. It doesn't require any formatting or it doesn't require any sort of predefined schema when we put the data over there. Now when I say schema, so what it looks like. So schema means that there would be certain specific columns. There would be for each and every column, there would be specific data types. And that's where the data can be loaded. Only the formatted data can be loaded over there. Where in data lake, it is not required. Now coming to data warehouse, it's a centralized system that stores and analyzes data from multiple sources to help business make informed decisions. Now, if I look at the last phrase, to help business make informed decisions, so that's where the essence of data warehouse lies. So obviously data warehouse, when we put any sort of data over there, it needs to have a schema. It needs to have a format or a predefined structure. When I was showing you the picture between between the different kinds of data, that is the structured, semi-structured, and unstructured, you could easily see and understand the structured data is the easiest form of visualization, where we can easily understand the attributes, the fields, the columns. So that kind of data is only supported in data warehouse. And in data warehouse, whenever we have to put the data, we have to make sure that the predefined schema or the table is already created for the same. Otherwise, we cannot put the data. So that is why any sort of unstructured or semi-structured data we cannot put into data warehouse. Now to summarize, let's talk about the differences between the data lake and the data warehouse and when should we use them. So the first key difference is the data structure, right? As I just mentioned, data lake stores raw and processed data in its native format. It supports both structured and unstructured data. So just highlight this thing, native format means whatever file format that is coming in whatever raw version file that is coming in, we can simply put it into the data structure without having to worry about its format, without having to worry about its schema, its structure, or anything for that matter. We can simply put the data and that's it. No need to worry about anything. Whereas for data warehouse, it stores processed and structured data organized into predefined schemas and tables. So in order to save them into data warehouse, it should have a structure, it should have a schema, and the table should already be presented. Only then we can put that structured data into tables, and inside the table, the format of the structure, that is the columns and the rows, we can easily analyze. So that is the basic difference and the most pivotal difference between a data lake and a data warehouse. Now the second one is the purpose. So when should we use a data lake and when should we use a data warehouse? Primarily, data lake is used for big data analytics, machine learning, and data exploration. It allows data scientists and analysts to access and analyze data without the constraints of a predefined schema. So when you see the word big data analytics, obviously I'm not talking about gigabytes or megabytes of data. It's like terabytes, petabytes, or even exabytes of data. And all those data we can simply dump into one single repository, which is known as the data lake. We don't have to create any schema. We don't have to make it structurized. We don't have to keep it in any specific format for us to understand the data. We just need a repository. We just need a file storage where we can simply push the data and that's it. Our job is done. So for big data analytics or for any sort of big data processing, data lake is used majorly. Now for data warehouse, it is designed for business intelligence and reporting. It provides a reliable and consistent source of data for decision making and operational reporting. So as I said earlier, right, if the business has to create some report, it has to generate a dashboard. In that case, it needs data in a structured way. It may not be a big data. It could be some small megabytes or say kilobytes of file. But for reporting purpose, it has to be in a proper structure. It has to have a predefined schema. So that's where the data warehouse comes into play. Now this is the second where I talk about when should we use the data lake and the data warehouse. The second key difference. The third one is the scalability. So this scalability, the term scalability means is expandability. So when you're putting some data into some repository or in any place for that matter, you have to make sure if the data is growing in that case, that storage also needs to be grown. The volume needs to be extended as and when the data grows. Data lake is highly scalable, capable of handling vast amounts of data from various sources. It can grow as needed without significant restructuring. So just in the previous example, I was talking about the big data analytics. And in the big data analytics, obviously today we have say 100 GB of file. 10 days later, we can have say 100 TBs of file or data. So I need a place, I need a repository where I can simply dump the data without having to worry about its storage or its volume. So data lake has that capability. data lake has that capability, you know, to handle that vast amounts of data. It can scale up to as much as we need, and it can easily put the higher volume data with ease. So that's how the data lake works. Whereas for data warehouse, it is scalable. It may require some more planning and resources to accommodate large volumes of data, especially as it involves data transformation and schema design. So for data warehouse, as I mentioned, that we should have a predefined schema, it should have a table, and then only data can be loaded over there. Even though some cases data warehouses can be scalable, but you have to make sure when the data is growing over there, we have to ensure that the schema incorporated with the newer data or the growing data is already present in the data warehouse. If the schema is changing, if some new columns are being added or some columns are being removed, we have to maintain the same thing in our existing data warehouse, otherwise it will fail. The loading will fail. So the scalability when it comes to data warehouse, it is a bit of a tedious job, and obviously it requires more cost and planning, to make it happen without any sort of failure. So that is the third key difference, that is the scalability or expandability. The next one is the data processing. Now, just look at this word schema on read, and the another one is the schema on write. Okay, data lake follows a schema on read approach, whereas data warehouse follows a schema on write approach. So what is the schema on read or schema on write, and why it is so significant for data lake and data warehouse? So you need to understand one thing. Schema on read means whenever I'm going to read a file, then only I need to impart the schema. Whereas for data warehouse or even for schema on write, whenever I'm loading the file, whenever I'm putting the file into some place, it should have the schema present. Okay. So for data warehouse, as I just mentioned, right, whenever I'm trying to load the file, it should have a predefined schema. It should have the table ready. Then only we can load the data into data warehouse. So that is why it is called schema on write. It's pretty understandable, right? But for data lake, I just said that there is no schema, right? There is no schema required, but it is showing schema on read approach. What it means. In the field of big data, there are some tools such as Apache Hive, Apache Spark. They actually help to impart a schema on top of the data that is residing on data lake. Now, what does it mean? In the data lake, we can have a semi-structured, unstructured, or even structured data. We don't need to worry about the schema over there. But tomorrow, if some business people or anyone is trying to analyze that data or read the data, there are some tools present which can impart the schema exclusively into those data, which means the data will reside on its own in the data lake and the schema will be a separate layer on it. And that's how they can analyze the data. Obviously, when I'll be covering Apache Spark or Apache Hive, you will understand how that works. But that is the basic difference. When we load the data into data lake, we don't need any schema, but in data warehouse, we do need the schema. That is why data lake follows a schema on read. While reading the data, we can impart a schema on top of it. But data warehouse schema on write means whenever I'm writing the data, the schema has to be present. Now the last one is some examples. So what are the examples or the tools that are being used in the data lake and in data warehouse? For the data lake, as I just said, right, it's much more like a file storage or a file manager. So the examples are Amazon S3, Azure Data Lake, Google Cloud Storage, or even Hadoop File Distributed File System, which is known as HDFS. So all these are just like file manager. You can create a folder, you can upload some files over there. It doesn't have to have any kind of schema or tables. You can simply upload the data and that's it, you're done. So that's how they work. But data warehouse such as Snowflake, Amazon Redshift, Google BigQuery, Azure Synapse Analytics, and Teradata. So over there, you have to create a database. You have to create a table on top of the database. It should have some predefined schema like the data types and all, and then only the similar format data which is conforming to the schema that are there, can be loaded. So all this Snowflake, Amazon Redshift, Google BigQuery, they only support the structured data, and they should have schema or tables already defined before loading the data onto them. So these are the key difference between the data lake and the data warehouse, and this is where we and these are the scenarios where we use the data lake and data warehouse. So that's all from today's session. Reach out to TechSpark for any help. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. We provide mentoring. We reach out to each and every candidate, and we just try to analyze or understand any candidate if any candidate is having any sort of issue in understanding any of the course topic. See you on the next session. Thank you all. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.